Alright, so hopefully you're working on trying the warm-up. You want to try to do that without the use of a calculator. Basically just some basic math facts to kind of review. So 16 plus 8 will give us 24. We have 13 times 4. That will give us 52. 34 minus 19 is 15. And 96 divided by 6 is 16. So 24, 52, 15, and 16 are the answers that you would have for those 4 warm-up problems. So today we're going to be looking at rational and irrational numbers. We're going to be talking about what is a rational number, what's an irrational number, and how do we tell which one it is. So we're basically looking today at classifying numbers. What sort of groups do they fit in? If you think back to 7th grade when you were learning about the different classifications of animals and you had kingdom, phylum, species, class, and all of that, we're doing something similar today, but we'll be doing it with numbers. So basically what I'm going to do here is here we're going to look at different types of numbers. The main grouping of numbers are known as the real numbers. And every number that you can think of is considered to be a real number. Underneath the real numbers, we have 2 categories. We have what are known as irrational numbers, and these are decimals that never end or repeat. The famous irrational number is pi. And another common one with pi is actually the square root of 2. They are your irrational numbers, decimals that never end and never repeat. On the other side are all the rest of our numbers. And all the rest of the numbers are known to be rational numbers. These are your fractions, your decimals, your percents, your integers, your whole numbers, negatives, positives, anything you can think of. The rational numbers then break down into integers and what are known as non-integers. Non-integers are going to be our decimals, and our decimals break down into terminating decimals and repeating. So non-integers break down into our terminating decimals and our repeating decimals. Our integers then break down into our negative numbers and our whole numbers. And it's broken down into negative and whole number instead of negative and positive is because whole numbers encompass all of the positives plus 0. Whereas if we just wrote positive numbers, 0 wouldn't be included. Whole numbers now break down, and we're actually going to break out the 0, and you'll have your positive numbers then over on the left-hand side. And the last step of the diagram is positive numbers actually then break down into odd and even. And then this is going to be the flow chart that we'll use to help us classify numbers. So for instance, if I said let's classify 4, you start at the bottom. 4 is even. Because it's even, we know it's a positive number. Because it's a positive number, we know it's a whole number. Because it's a whole number, we know it's an integer. Because it's an integer, we know it's rational. Because it's rational, we know it's real. Or maybe I give you the decimal point 333 repeating. You would say repeating decimal, non-integer, rational number, and real number. So you want to start at the bottom of the document and then work your way up towards the top, kind of following the little arrows as we go. So here we're looking at the actual definition of a rational number. A rational number is a number that can be written as the quotient of 2 integers. Quotient of 2 integers is just a very, very fancy way of saying fraction. So a rational number is any number at all that we can come up with a way to write it as a fraction. So in the examples down here, all we're going to do is, can we write these numbers as fractions? If we can, they're rational. If we can't, they're irrational. So 7 can be written as the fraction 7 over 1. Negative 10 can be written as negative 10 over 1. Now with 3 and 4, these are currently mixed numbers. We can change them, and we will change them into improper fractions. So 4 times 5 is 20, plus 3 is 23 over 4. Remember with problem number 4, we're going to forget about the negative for right now. 2 times 3 is 6, plus 1 is 7 over 2. And then we will bring the negative over to make it negative 7 over 2. So because we could write all of these as fractions, we therefore know that all of these examples are rational numbers. On the other hand, here we have irrational numbers. An irrational number is a number that cannot be written as the quotient of two integers. It can't be written as a fraction. An easier way to determine if something is rational or irrational is actually to look at the decimals. When you change something into a decimal, if that decimal never ends or never repeats, then it is considered to be irrational. Now, for our purposes, we're going to be doing this on a calculator. And on the calculator, if it looks like it never ends or if it looks like it never repeats, we're going to consider it to be irrational. Okay? I'm not going to give you one that stops after the end of your calculator screen. So these 4 examples down here are all examples of irrational numbers. We've talked about pi before. We've talked about the square root of 2 before being irrational. 2 is irrational. You'll notice that it does have a pattern, but it's not a consistent repeating pattern. If the pattern was always 0.20202020, that would be repeating and it would be considered rational. But because this pattern itself doesn't repeat, it is considered to be irrational. And the square root of 3 is also irrational as well. So here are just some practice problems you want to go through. You want to determine if they're rational or irrational. And you're going to want to use your calculator. So, first of all, 0.87, get back to the pen here, that is going to be rational because I can write it as 87 over 100. 2, it's kind of hard to see here, but 2 is the square root of 4, which is 2. So it's rational. I can write it as 2 over 1. 3, very similar to the second problem on the last slide. 3 is irrational because, yes, it does have a pattern, but that pattern is not repeating. And then number 4, this is going to give us negative 17 over 7 as a fraction, so therefore it is rational. Square root of 2, we've already talked about that is irrational. 629, that is rational. I can write it as 29 over 1. 7.3, this is going to be rational. It's going to be 3 over 10. And pi, number 8, of course, irrational. Last example for today is really just calculator work. You're going to want to plug these into the calculator and see what you get as your decimal. And then you want to tell me if the decimal terminates, meaning it ends, or it repeats. So 1/5. When you put this into your calculator, you're going to do 1 divided by 5. Right in order, numerator, division sign, denominator. 1 divided by 5 is 0.2, and we're going to write a t because 0.2 terminates. 19 over 6, when you do that in division in your calculator, you're going to get 3.16 with the 6 repeating, so therefore it's a repeating decimal. The repetend bar is the name of the bar that goes over the repeating parts. It only goes over the 6 because the 6 is the only number that continues to repeat in the pattern. 3. 8 and 5 over 44. First of all, the 8 out front here is going to be the whole number that goes in front of the decimal. So the only thing I'm going to plug into the calculator is the 5 over 44. 5 over 44 is 0.1136 with the 36 repeating, so therefore it's a repeating decimal. And then we have 7 over 12, that's 0.583. 3, with the 3 repeating, so again a repeating decimal. And then that's the end of this lesson. You should have a worksheet now to work on, or if you're just reviewing this in preparation for a test, maybe pull out your homework worksheet, look over it, make sure you're okay with all of those types of problems.